Welcome to week 4 of distance learning. This is the Algebra class, Heritage High School. I'm Mr. Leong, and this week, all we really got going on is an assessment. So you guys have a quiz that you're going to take on quizzes, and then what we're going to go through here is the practice quiz, which you can also take on quizzes, but you should also have like either digital or paper copies of these quiz questions in your teacher packets. All right, so before I begin, I have a special request from a couple of my students who wanted to see me draw a banner and an airplane. So I'm going to go ahead and do that here for the title. So not sure why we're so interested in this, but you know, whatever is going to make you guys happy and smile during this time, you know, I'm willing to do. So there's my generic little airplane and quizzes banner. All right, so let's get into the algebra here. So the first couple questions are more like vocabulary, and then we're gonna, you know, start doing some calculations, looking at graphs of quadratic functions. All right. So question number 1. What is the vertex in the quadratic equation? Now, if you've forgotten the meaning of this word, I will drop a little hint here. So you can refer to page 420 in your textbook. Okay. Visually, the vertex is a very special, a very unique point on a parabola. Okay. It's kind of like the point where the parabola changes direction. So it may be going down and then up, or up and then down, okay? So the vertex is kind of where it bottoms out or where it peaks, okay? So that makes C the clear answer, right? It's the highest or lowest point on the parabola. All right, question number 2. What is the vertical line that divides the parabola into 2 symmetric parts? Okay, so again, the definition is on page 420 in your textbook. Okay. All right. So we know that a parabola is this very symmetric curve, and because of its symmetry, you can divide it into 2 mirror images. All right. Notice we're drawing a vertical line that passes through the vertex. Okay. So the name given to this line here that I've done in pink it is called the axis of symmetry. That one was kind of, I mean, if you just kind of look at the question, right, you see the word symmetrical in the question, and the word symmetry is in the name of this line. So, all right. So now we're going to talk about calculating the axis of symmetry, right? So if you just have a quadratic function, right, how would you know, right, you know, relative to your x-axis where that vertical line is? Okay. So we have a formula for that, and this is, you know, one of the few formulas that you might want to memorize for this particular quiz. The axis of symmetry will cross the x-axis at -b/2a. All right, so what do these letters B and A stand for? Well, they refer to the coefficients in the quadratic function. Okay, so the coefficient on the squared term, that's your A value. The coefficient on your first degree term, that's your B value. The constant is your C value. Okay. So for this particular quadratic function, we're going to substitute -6 in the numerator and +3 in the denominator here. All right, let's work it out. So x equals the negative of -6, right? So keep in mind there's a negative in the formula, and then there's a negative in the coefficient, right? So then we're going to end up with 2 negative signs here, divided by 2 times the a value, which is 3. Okay, so we're going to have +6 over +6, or just 1. Okay. So the axis of symmetry will hit the x-axis at +1. Question 4, what's the vertex? Well, so the vertex is a point. So points have two coordinates. Let's just redraw it again. So the vertex is going to have an x coordinate, and it's also going to have a y coordinate. Now the x coordinate we can find, okay, because it coincides with the axis of symmetry, right? So I'll use the same exact formula here on question 3 to get the x coordinate of the vertex here in question 4. Okay. But how do we get the y coordinate? Well, remember, before we learned this function notation, right, we would write equations using the form, y equals negative x squared minus 4x plus 12, right? So these are similar ways of writing a function. You can use function notation or you can use y notation. Okay. So the function itself is how we're going to get the y coordinate. Okay, so let's go ahead and start by finding the x coordinate first. So we can put, it's too small here, so let's write it here. Write it as negative 1x squared minus 4x plus 12. Okay. So this is my a value, my b value, and my c value. Okay, so x is equal to negative b over 2a. That's going to be the negative of negative 4 over 2 times negative 1. Okay, so the b value is negative 4, the a value is negative 1. So that's positive 4 over negative 2, or just negative 2. Okay, so right away we can cross off c and cross off b, because those both have positive 2 as the x coordinate, and we know that it's going to be negative 2. Okay. All right, now to determine the y coordinate, we can just use the function itself. Use negative 2 in place of the variable x. Right, so y will equal the negative of negative 2 squared minus 4 times negative 2 plus 12. Okay, getting off screen there. Okay, so that's going to be the negative of 4, and that's going to be positive 8. That's going to be 12. Okay, negative 4 and 8 is 4, plus 12 more. So it should be 16. 16, so negative 2, 16 would make A the correct answer choice. Okay, so you're going to do this problem in 2 parts, right? In the first part, you find the x coordinate, and then in the second part, you find the y coordinate. All right. So question 5, 6, and 7 are kind of like testing your ability to identify certain parts within the graph itself. So question 5, we want to find the vertex. Remember, that's either going to be where the graph bottoms out or where it peaks. And so we can just label it there. And then you can see that the x coordinate is 2 and the y coordinate is 4. Okay, so 2, 4. All right, number 6, now we want to find the x-intercepts. Right? So where does our parabola cross the x-axis? And this one crosses in 2 spots, right? Crosses at that point and that point there. And that was 0 and that was 4. Okay, so 0 and 4. All right. Number 7, now we're looking for the y-intercept. Okay, so where on the y-axis does our curve parabola cross? And it looks like it's right there at 5. Okay, so 0, 5. 8 is a question about the domain, which are the possible x values on our parabola. So, I don't know, I think most students kind of have a difficult time with domain and range. And I'm sure teachers probably have a difficult time teaching it too. It's a very, I don't know, maybe abstract concept. But so let's try to just make a list of all the x values that we see on this curve, right? And I'm just gonna just pick random points along the curve. Well, not so random, but points along the curve. So that point there has an x-coordinate of 4. So I know 4 is in the domain. That point there has an x-coordinate of 5. And we see 6 would be an x-coordinate. There's a point right here where 7 would be the x-coordinate, right? And so we can just keep picking more and more points, right? And we can see the x-coordinates just keep getting bigger and bigger, right? So they'll keep going as big a number, as big an integer as we want. And if we pick points on this side of the parabola, like if I pick that point there, it has an x-coordinate of 3, so 3 is in the domain. That point has an x-coordinate of 2, so 2 is in the domain, right? And we can just pick more and more points going more and more to the left, right? The parabola extends forever, right? Both left and right, okay? But then keep in mind that we don't have to pick those particular points. We can pick points in between, right? So there'll be fractional values and decimal values that we can use as x-coordinates, as x values, right? But the idea here is once we realize that, you know, as integers, any positive integer is going to appear as an x-coordinate and any negative integer will appear as an x-coordinate. And then we remember, oh yeah, points in between the integers will also appear as x-coordinates. That leads you to the realization that any number, right? Any real number, so an integer, a whole number, a fraction, a decimal, right, can be used as an x-coordinate. Right. 9, so now we turn our attention to the range, and the range refers to the y values on the graph. Okay. So let's just start making a list, right? So I'll look at this point right here, which I can see has a y value of -1. And then this point here has a y value of -2. Should be going this way. And then that point has a y value of, well, that's -1, -2. So that one right there would be -3. And that would be -4, right? And so as I'm picking points further and further down, right, I see that the y coordinates can become smaller and smaller and smaller. Okay, if we look at the other side, right, this point right here has a y coordinate of -2, which is already on my list, right? That point would have a y coordinate of -3, which is just a duplicate, -4, -5, -6, -7, -8. So the y values on this parabola can get smaller and smaller and smaller, but they're never going to get larger than -1. Okay, so as a list, okay, the y values kind of max out at -1, but they can be smaller. And then we have to remember that there can be, you know, decimal and fractional y coordinates as well. But if we just try to describe this list of numbers in words, it would be numbers less than or equal to -1. Okay. Now replace the word numbers with the variable y, replace the phrase less than or equal to with the symbol less than or equal to, and then -1 is just a number. So we kind of went through this thought process of, okay, let's pick out certain points along the parabola and just write a list of the y values, okay? And then we'll describe that list using words, and then we'll convert that sentence into a symbolic expression, okay? So y values numbers that are less than or equal to -1. So that's going to be answer choice B. All right, so let's take a look at this function, and then we will match it to one of these 4 graphs. The first thing that I notice is that there is a negative sign on the squared term, okay? So that already tells me that the parabola is going to be concave down, okay? So we can cross off B, and we can cross off C. Next, I might want to figure out where the axis of symmetry is, right? So if I look at these 2 graphs, they have the same y-intercept at -2, right? Which makes sense because that's the constant in the function, so that doesn't really help us differentiate the two. But choice A has an axis of symmetry that passes through -1, and choice D has an axis of symmetry that passes through a point +1. I don't know if I said -1 here. I meant -1 for graph A and +1 for graph D. So if we can just calculate the axis of symmetry, then we can determine which of these two graphs is the correct one. So let's just write it in. So that's -1x squared minus 2x minus 2. So that's my A, that's my B, and that's my C. All right, so x equals -b over 2a. So that's going to be the negative of -2 over 2 times -1, which is going to be +2 over -2, which is going to be -1. Okay. So our parabola will have an axis of symmetry that hits at -1, which makes A the correct answer. Right, look where that pink line is, it hits at -1. 11 looks like it's the same kind of question. We have a quadratic function, we have 4 different graphs, we just got to match it up. Okay, same thing, the second degree term has a negative sign in front of it, so that means that the parabola will be opening down. That's what the negative sign tells us there. So it's not A, and it's not going to be B. Now, if we look at choices C and D, right, they both have the same y-intercept. Oh, no, they don't. So this one has a y-intercept at, let me highlight it here, +9, and this one shows a y-intercept at -9. The y-intercept is going to be related to the constant part of the function, right? It's the result you get when you substitute 0 for the x coordinate. Okay. So since it's +9, the parabola will intercept the y-axis at +9. And we can just verify that by substituting 0 into our function, right? -3 times 0 squared plus 6 times 0 plus 9. So that term is 0, that term is 0, and then all we have is the 9. Okay, so now we are shifting from like standard form of a quadratic function to vertex form. And so vertex form generally looks like this. Y equals A times x minus h squared plus k. Right. So the different letters here represent different features of the parabola. So the A is going to be a stretch or shrink factor. Also, if A is negative, it will represent a reflection. H is going to be a horizontal shift. Okay. So if H is a negative value, we shift to the left. If H is a positive value, we shift to the right. Okay. And then K is a vertical shift. Okay. K is positive, we shift up. K negative, we shift down. And H and K also represent the coordinates of the vertex too. So probably should have mentioned that. All right, so if the equation is 3 times x plus 5 squared minus 4, what is the vertex of the parabola? Well, right away, I want you to notice that in the formula I wrote, I've got a minus sign here and a plus sign there. And in the function that they have a plus and a minus. Okay, so we need to get these signs to match up. So I'm going to rewrite this right, as y equals 3 times. Now, x plus 5 is equivalent to x minus negative 5. And minus 4 is the same as plus negative 4. So I'm doing this so that the function here in the problem matches its signs with the formula. So we want to see a minus sign directly after x, and we want to see a plus sign in front of our constant. All right, so this tells us that the h value is negative 5 and the k value is negative 4. And so those are going to be the coordinates of our vertex, negative 5 and negative 4. That's choice B. All right. 13, same kind of question. What's the vertex? And so if we just check the signs in the function, we do have a minus sign after the variable x, and we do have a plus sign in front of the constant, which matches the signs in our formula. Okay. So that tells us directly that the h value is 3 and the k value is 6. So 3, 6. All right, 14. The function is x squared minus 7, and we want to compare that to just your basic parabola x squared. Right, so remember that your basic parabola is going to have its vertex at the origin at 0, 0. Right. And a moment ago, we talked about this formula here and how the constant part represents a vertical shift, right? So, if this were +1, then the parabola would just shift up 1 space. If it was +2, it would shift up 2 spaces. If it was -1, then it would shift down a space or whatever, right? So the fact that we see a constant of -7 is telling us that our original parabola is just going to drop down, shift down 7 spaces, right? 1, 2, 3, 4, 5, 6, 7. Right, and I'll use another color here. Okay, so that's what the -7 is doing. Okay, it's shifting it down. Okay, so we need the answer choice that says down. Right, 15. We've got x plus 10 squared, and we want to compare that to the parent function. Okay. So remember, we had y equals a times x minus h squared plus k. Now, before you get too deep into this problem, just recognize that the function here has a plus sign, but in our formula we have a minus sign. So we're just going to rewrite it real quick. So this is the same as x minus negative 10 squared. And so now you can see that our h value is negative. Okay. And if we think about our axes, right? Negative numbers are on this side of the x-axis. Positive numbers are on that side. Okay. And h is a horizontal shift. So the fact that h is negative is telling us the parabola is going to shift towards the negative side of the number line, so that's to the left. Now, something that you can do here, right, just for extra convincing, because I know a lot of students will see, oh, x plus 10. They'll think positive 10, they'll think to the right, okay? So like when you're first beginning to deal with vertex form, it's always a good idea to just graph it, like use a graphing calculator, use Desmos, right? And then just type the function in. So type this function, and compare the two, right? So you kind of have to build your intuition for these kind of problems, because your natural instinct is to think plus 10 goes to the right, but in reality, it's the exact opposite of what you would intuitively think. All right, 16. So we've got finally a coefficient in front, okay, and then we have a horizontal shift value and a vertical shift value. Again, I'm going to match the signs up so that I have minus and plus. Okay, so I really would like to have a minus sign here and a plus sign here. So we can write it as y equals 5 times x minus -6 squared plus -4. Okay, so that achieves my goal of just getting the signs to match the formula there. So this is our A value, right? It's the stretch or shrink factor, okay? This is our H value. It's the horizontal shift number. And then this is the K value. It's the vertical shift value. So we know that if H is negative, that's going to be to the left. So just put L. If K is negative, that's going to be down. Let's draw an arrow. Arrow pointing to the left and arrow pointing down. Okay, so let's just look for answer choices that say 6 to the left and 4 down. 6 to 4 up, so it's not A. 6 right, so it's not C. 6 left, 4 down. 6 right, so it's not D either. So it's got to be B, process of elimination. Okay. Now, we didn't talk about that A value. We didn't need to, but for the sake of completeness, that A value is a stretch or shrink factor. Okay. If it's bigger than 1, it stretches the parabola. If it's less than 1, it shrinks the parabola. So the word stretch there does indeed match with the fact that 5 is bigger than 1. All right, 17. So we've got a parabola and we want to write the function. So I can see the vertex there has coordinates -2, -1. Okay. And remember that these are also the H and K values, right, in the vertex form. So I know the H value is -2 and the K value is -1. Okay. I also see that the parabola is opening upwards. Right, both the left and right branches of the parabola are going up. So that tells me that the squared term in the function has to be positive. So I can already eliminate C and D, right? Because they both have negative signs in front of the squared term. And that would only make sense if the parabola was opening down, which it's not. All right, so let's start with y equals a times x minus h squared plus k. But now we actually have values, right? An h value and a k value that we can substitute in here, right? We don't have an a value, right? That's probably not going to be important. If you look at the answer choices, there's no a value there, so you can just assume it's going to be a 1. Okay. So let's go ahead and plug -2 in place of h and -1 in place of k. Y equals a x minus -2 plus -1, right? So there's 2 minus signs here, right? There's a minus sign from the formula, and then there's also the negative sign from the h value. All right, and then when you simplify that out, we get y equals a x plus 2 squared minus 1. So we know that the function of this parabola is going to have an x plus 2 as its squared term, and then a -1 as its constant term. And so that would make B the correct answer. Okay, and now we reach our final question. I think 18 is the last one. Yeah. So we have a verbal description of the parabola. All right. It's translated 3 units to the left, and then it reflects over the x-axis. So if I were to just kind of sketch this, 3 units to the left, right? And so normally it would open up like this. 3 units to the left means now it's over here. And then reflect over the x-axis. Well, that's our x-axis. We're going to flip it over it. So now it's going to look like that. So this is the end result that we get after we follow all those descriptions. Shift it to the left and then reflect it down. All right, so because it's opening down, we know that there must be a negative sign in front of the squared term. Okay, so this squared term does not have a negative sign, so that can't be it. That squared term doesn't have a negative sign, that can't be it. Both of these squared terms have negative signs, so they're still in the running. We also know that, let's see, this point, right, is going to have an x-coordinate of -3. The y-coordinate we don't know yet. Okay. But the x-coordinate is -3 because it did shift 3 units to the left, right? And that's our h value. So if we were to start with the generic expression y equals a, x minus h squared plus k, right? Because of the reflection, we know that a is going to be negative, right? And because h is related to the horizontal shift, and we've gone 3 units left, right? That's how we know the h value will be -3. All right. Now here's again where you got to pay attention to signs, right? There's a minus sign from the formula and there's a negative sign from the h value. So we end up with 2 negative signs or 2 minus signs, however you want to describe it. And then the k value we don't know, so I'll just leave it as k. So simplifying, we get y equals -x plus 3 squared plus k. Now we already knew that we need a negative sign in front, and now we know that we want to see x plus 3 in the function. And choice B is the only one that has those qualities. So I'm sure this video was kind of long. We went through all 18 problems. So thank you for watching the video. Again, you know, you can go back and rewatch it if there are any problems that, you know, gave you a particularly hard time. And then good luck on the quiz. All right, thank you for watching.